Okay, so let's just dive right in. Behind every app you use, every website you visit, every single piece of tech in your life, there are these hidden rules. It's like a secret language that makes it all work. Today, we're going to pull back that curtain and take a look.
I mean, really think about it for a second. You open your photo gallery and bam, you can find a picture from 3 years ago just like that. Or you start typing a name in your contacts and it pops up before you're even done. How on earth is that possible with the insane amount of stuff we all have on our phones?
Well, the answer is actually pretty simple. It's all about organization. But we're not just talking about being neat and tidy. No, this is a very specific, super engineered system of organization that lets our tech be incredibly fast and efficient.
So here's the game plan for this explainer. First, we'll get into why we even need to organize data in the first place. Then we'll check out the toolkit programmers use to get the job done. We're going to explore two main strategies. One is about lining data up, and the other is about connecting the dots. We'll also touch on how to make it all run smoothly, and then for the big finish, we'll show you where these hidden structures are hiding in your everyday life.
All right, first things first, why is this even a big deal? Well, to put it lightly, we're living in an age of absolute digital chaos. The amount of data being created every single second is just mind-boggling, and our devices have to somehow make sense of it all. You see, as our apps get way more complex and the data they handle just keeps exploding, we start running into some major roadblocks. Without some smart organization, processing speed would just grind to a halt. Trying to find one email would be like looking for a needle in a global haystack. And can you imagine your phone trying to handle texts, stream music, and give you map directions all at once without a system? It would be a complete and total mess.
So, how do we fix this chaos? Well, this brings us to the absolute core of our explainer, the Organizer's Toolkit. And in the programming world, these tools are called data structures.
A data structure isn't just a box you throw stuff into. It's a blueprint. It's a really specific, systematic way of arranging data in a computer's memory that also defines what you're allowed to do with that data. It's the difference between having a giant pile of books on the floor and having a library with a card catalog system.
This here gives us a kind of map of the different kinds of data structures out there. You can see it splits into two big categories. We're going to focus on those two main branches on the right, linear and nonlinear. These are two totally different ways to think about organizing information.
Let's start with that first branch, linear structures. And yeah, it's pretty much what it sounds like. This is all about putting your data in a sequence, one thing after another, kind of like beads on a string.
Now, the most basic linear structure is something called an array. And honestly, the best way to picture this is like an egg carton. It has a fixed number of spots, say 12, and every single spot is numbered. So if you want the egg in slot number 8, you can just go right to it. It's incredibly fast to grab any item as long as you know its position or its index.
But what happens if you don't know how many eggs you're gonna need? That's where a linked list comes in. This is a totally different approach. Think of it like a treasure hunt. You start at the first item, and it holds some data, but it also holds a clue that points you to where the next item is. And that one points to the next, and so on, until you get to the very end of the chain.
So, this is the crucial part. There's a trade-off. With an array, you get that lightning-fast access, but its size is totally fixed. Trying to add a 13th egg to a full carton is a big problem. With a linked list, getting to a specific item takes longer because you got to follow that chain. But adding a new one is super easy. This choice makes a huge difference. An array is great for your phone's home screen where the grid of apps is static. But a linked list is perfect for your music playlist where you're always adding, removing, and shuffling songs around.
Okay, but not all data fits neatly into a single line, right? Sometimes the most important thing isn't the sequence, it's the relationships between the items. And this is where we get into our second major category, nonlinear structures.
A perfect example of a nonlinear structure is a tree. Just think about the file system on your computer. You've got a main root folder, right? And inside that folder, you've got children, which are other folders. And each of those children can have their own children. And on it goes. This hierarchy is exactly why finding a file is so fast. The computer doesn't have to look everywhere. It just follows the right branches down the tree.
But what if there isn't a clear hierarchy? What if anything can connect to anything else? Well, for that, we use a graph. A graph is really just a bunch of points or nodes that are connected by lines or edges. Think about a social network. You're a node, your friends are nodes, and those friendships are the edges connecting you all. It is the perfect way to map out these complex, tangled networks.
Okay, so we've got these incredible ways to organize all our data, but just having it organized isn't really enough. We need to do things with it. We need to search it, sort it, add new stuff, and that, my friends, is where algorithms come in.
To put it simply, an algorithm is just a recipe. It's a super precise set of instructions for a computer to follow to get a job done. So if a data structure is the library, an algorithm is the set of instructions for how to find a specific book or how to put a new book on exactly the right shelf.
And this is a really critical question. For any one task, there could be dozens of different recipes to get it done. To find a contact in your phone, one algorithm could be to start at A and check every single name. A much better one might be to jump straight to the right letter. So how does a programmer choose?
Well, they analyze its performance, especially what's called the worst case. This graph kind of shows the key question they ask. As the pile of data gets bigger and bigger, how much slower does my algorithm get? They always plan for the toughest possible scenario, like searching for a name that isn't even there, to make sure that even under maximum stress, your app doesn't freeze up. It stays fast and reliable.
So now we've covered the what and the why. Let's get to the really fun part, connecting all these abstract ideas to the tech you use every single day. I think you're going to be surprised by how many of these you already know.
Seriously, they are everywhere. When Google Maps finds you the fastest route, that's a graph at work. When your keyboard suggests the next word as you type, it's searching a tree of possibilities. Ever hit the undo button? You're using a stack, a structure where the last thing you did is the first thing that comes out. Your printer lining up documents to print, that's a queue, where it's first in, first out. And your phone's contact list? It uses a super fast structure called a hash table to find a name instantly. It's like a magical index for your data.
And this quote from our source material just sums it all up perfectly. Choosing the right data structure isn't just some boring academic thing. It's what makes our digital lives feel so seamless and fast. It saves time for the program, which means it saves time for you. So the next time you use an app, just take a second and think about the invisible organization that's humming away underneath it all. Now that you know the hidden rules of the digital world, you might just start seeing these structures everywhere. What other parts of your life, digital or not, are secretly built on these powerful ideas?